Question 59, you've got another pulley system. This time we've got a mass here, and it's being pulled towards the pulley there. So we'll put some tension in it there. And you've also got the weight here of 2 kilograms. So I've got 2G pulling it downwards, and we've got the tension pulling it up there. This says it's a smooth table, so we haven't got any force pulling it backwards there. And if you read through it, it actually says that this wire's 1 meter long, and so it's hanging down 0.5 meters, and it's 0.5 meters from the pulley there as well. Let's get on and try the question. At A, what's happening at A? At A, you've got the tension pulling it towards the pulley, nothing else, so the tension equals the mass times the acceleration. At B, you've got the 2G pulling it down and the tension stopping it, so 2G minus T equals the mass times the acceleration. Now if I add those two equations together, the T's magically cancel out, and I've got 2G equals 5A. So I've found out what the acceleration is. The acceleration is 2/5 G. You might be saying, well, I don't need to do that, but you need it in a minute. Now I've got what the acceleration is, I can throw it back in here and find out what the tension is. So the tension is 3 lots of 2/5 G, and I'm still going to work in fractions for a bit longer. So I've got the tension is 6/5 of G. Now on that pulley there, you've got 6/5 G pulling it that way. You've got 6/5 G pulling it there as well, and it's nicely at a 90-degree angle. And so we can just use Pythagoras to try and figure out what the resultant force between the two of those is. It's just square it, add square root. And I'll change, I mean, I've got 6√2/5G for that, but actually as a decimal, it's 16.6 newtons. Just jumping through to part C here, how have I used the fact that the pulley is smooth? I mean, the fact that the pulley is smooth, I'm using that these two tensions are both the same there. That's how I've used that the tension's smooth, that the pulley is smooth. Right, find the speed. So we're now going off for a Suvat equation. And it starts obviously at rest. The velocity is what we're trying to find out. The acceleration, said that would become useful, didn't I? So that's 2/5 of G. The distance, and the distance that one had to travel was 0.5 meters. And I'm not really worried about the time there. So I'm just going to use a V equals U plus AT here. V equals 0 plus 2/5 of G times 0.5. And so the velocity it hits the pulley at is 1.96 meters per second. Now, for the last part, and as this is question 59, virtually the last one, I'll be honest, I haven't got the right answer yet. So maybe you could put in the comments what the right answer is. What I have figured out is that when this has reached here, this pulley now is, this weight here is now down here, and this length there to there is 1 meter. So until it hits the ground, I think I've got 0.3 meters to go. So I think I've got a distance of 0.3 meters to go. I think I've got an acceleration now of G, because the rope's broken, there's nothing holding it up at all. And I think the initial velocity of this thing is the final velocity of that one there, 1.96. And the question says, find out the time. So I've used an S equals UT plus half AT squared. I've put in all my values. I've checked that this is, I mean, look, that's going downwards, and that's going downwards. So I've got all the same signs for all of these. 1.96t plus a half gt squared. I've solved that using the quadratic solver of the calculator, and I've got the time is 0.118 seconds. Now the answer in the back of the book here, the answer given is 0.250. So I've got that wrong. So as it's the last video, I'm going to leave you to figure out what I did wrong. Please put it in the comment underneath.